Assalamualaikum everyone. I am Sulaiman Shamim. The last four digits of my ID is 1211. Today my presentation topic is about process synchronization. Common synchronization problem. Race condition. A race condition occurs when two or more processes or threads access shared data simultaneously and the outcome depends on the order of execution. Deadlock. Deadlock occurs when two or more processes are each waiting for the other to release a resource, causing the system to freeze. Last is starvation. Starvation happens when a process is perpetually denied access to a resource because other processes are continuously favored. Before starting an explanation of code, first understand the few terms used in the above code. In used in a producer code represent the next empty buffer. Out used in consumer code represent first filled buffer. Count keeps the count number of elements in the buffer. Count count is further divided into three line code represented in the block in both the producer and consumer code. There are two types of semaphores: binary semaphore, counting semaphore. A binary semaphore can have only two integer values, 0 or 1. It's simpler to implement and provides mutual exclusion. We can use a binary semaphore to solve the critical section problem. Some experienced readers might confuse binary semaphore with mutex. There is a common misconception that they can be used interchangeably, but in fact, a semaphore is a signaling mechanism, while on the other hand, a mutex is a locking mechanism. So we need to know the binary semaphore is not a mutex. Here you can see the here we have a code and the explanation of the code. Here we have producer consumer problem count. Here the code is written in C++. Here let me show you the uh, details of the code, the application of the code. Yeah, here it is shown that if you talk about producer code first, RP is a register which keeps the value of m count, and next the RP is incremented as element has been added to buffer. And next, an incremented value of RP is stored back to m count, which is this explains the code. Here you can see that I have taken count 0 and taken the function void producer void and taken an integer and run a while loop. In the while loop, I have given this logic that while count equal n, then buffer in equal item p and in equal in plus 1, which would be mod n, and next line the count equal count plus 1. This is the logic. And lastly, the memory management: load RP m count and increment RP, store m count RP. Here in this part, last part, the memory, the after running the code, which the execution part is stored here in the last part. Lastly, I'm going to explain the summary. Process synchronization in operating system. Short summary: process synchronization is a technique used in operating system to manage the execution of processes that share resources, ensuring data consistency and avoiding conflicts. It is essential in multi-processing environments where multiple processes may try to access shared memory or files simultaneously. Key concepts: in the key concepts, we have a critical section, race condition, mutual exclusion, synchronization mechanism. In critical section, we have a part of code where shared resources are accessed. Race condition means a situation where multiple processes access and modify shared data concurrently, leading to unpredictable results. Mutual exclusion means exclusion ensures that only one process can enter the critical section at a time. That means that only one process can go at a time, not more than one process can go in a CPU at a time. Synchronization mechanism locks mutexes allow only one process to access the critical section. Semaphores, a signaling mechanism to control access to shared resources. And lastly, we have monitors, high-level synchronization construct that manages shared data with mutual exclusion. So that is my summary. Thank you for all for staying with me. I hope you like my invention.